Hey all, in this lesson we're going to talk about similar triangles specifically. In the last lesson we talked about similar polygons. Today we're going to talk about similar triangles, and it's kind of closely related to congruent triangles, but in this case we're going to try and show that triangles are similar, meaning remember they have all corresponding angle pairs congruent and all corresponding side pairs are in proportion, meaning if we write a fraction of their side lengths, they'll be the same. So there's three ways. I've got two ways right here, and we'll get to the third one. One way to show that two triangles are similar is simply by knowing that two pairs of angles are congruent. And we call that angle-angle similarity. And we'll use this squiggle, the similar symbol, to talk about the theorems that show triangles similar. So if we know that two pairs of angles are congruent, then we know then that the third pair of angles will be congruent because all angles in a triangle add to 180, and therefore we can say the triangles are going to be similar. Another way is side angle side, and we have side angle side congruence, and we also have side angle side similarity. So this time we're not looking for pairs of congruent sides, we're looking for pairs of sides that have the same ratio, which means they're in proportion. So I have two pairs of proportional sides, and then the angles that are between those sides, if they're congruent, we have side angle side similarity. Remember, it's very important I underline the word between. I'll do it again. The angles have to be between the sides that we're using to write the proportion and say I have two pairs of sides in proportion. The third one is side, side, side. Again, we had side, side, side for congruence, but we also have side, side, side for similarity. That means that we have all three pairs of corresponding sides in proportion. So if I write a fraction for all three pairs of corresponding sides, all those fractions will simplify to be the same fraction. And then we could say the two triangles are similar. So we're going to look at some similar triangles, and we are going to determine which theorem will prove that they're similar. So in this example, I want to know which theorem is going to show these two triangles similar. Well, first I need to assess the information that I have. Right now I'm looking only at values for angle measures. So I'm not going to be able to do anything using side angle side similarity or side side side. So I need to see if I have angle angle. Remember from a while back, and we've been doing these for a long time, I have vertical angles here. So I know that since this is 35, this angle is 35. And then we also know that in triangles, the angles add up to 180. So this angle of 45, this angle of 35, and this angle we don't quite know need to add up to 180. Well, if we figure out what this angle is, 180 minus 35 minus 45, that tells us that that angle is 100. And now I can see I have one pair of congruent angles, and those angles are also congruent. So these two triangles here will be congruent by angle-angle similarity. I want you to pause here, and I want you to see if you can pick the theorem that proves these two triangles congruent. I'll give you a hint. We don't know anything about their angles, so we can eliminate two options right away. Just make sure that the third option works. So like I said, we can eliminate angle-angle because we don't know anything about the angles. You can see that there's nothing written about these angles in here. And also we can't do side angle side for that very reason because we don't have any information about the angles. So let's check to see if side, side, side works here to prove that these triangles are similar. So I'm going to write the ratios of the corresponding side lengths and see if they all create the same fraction. So my smallest side in that triangle should correspond to the smaller side in this triangle. So I'll write a ratio from the triangle on the left to the triangle on the right. That's 2 over 3. Now my second biggest side over here is 3, and over here is 4.5. So I can write that ratio or that fraction. And last but not least, 4 over 6. So this 2 over 3 doesn't simplify any further, so I need to see if these two fractions reduce to 2 over 3. Well, in this one over here, 4 over 6, I know that 4 and 6 are both divisible by 2. And that simplifies to be 2/3. 3 over 4.5 is a little tricky. I can see that if I divide 3 and 4.5 both by 1.5, I get 3 divided by 1.5 is 2. 4.5 divided by 1.5 is 3. So I have a scale factor of 2 over 3. All the corresponding sides create the same fraction, 2 over 3. So these two triangles are similar by side, side, side similarity. Real quick, another way to check that is we can put 2 over 3 in our calculator, and we'll get 0.6 repeating. If we put 3 over 4.5 in, you'll get the same decimal, which tells you that the fraction would be the same. So I want you to go ahead and try this one. I'll tell you right now, these two triangles are definitely similar. I want you to tell me which of the 3 theorems proves they're similar. You should show your work, show what you did, maybe write a little something about it if you have to, of why you chose that theorem, and then we'll discuss it in class.